Find the general solution by variation of parameters method. So we got a second order linear non-homogeneous ODE. So the solution is given by a sum of complementary and a particular solution. So we first consider the corresponding homogeneous. That means we just take the right hand side 0. So consider y double prime minus 2y prime equals 0. Okay, homogeneous. And to solve this, we find the characteristic equation, which is r squared minus 2r, okay, equals 0. Let's solve for r. R squared means we should have two roots, okay, two values of r counting multiplicities. Here r factors out from both. R minus 2 equals 0. Sometimes this might not factor. You might have like 3 terms. In that case, you need to use the quadratic formula. So r equals 0 or r minus 2 0 means r 0, r minus 2 0 means 2. So we got two roots, two values of r. Based on these two, the solutions are e raised to 0t and e raised to 2t. E raised to 0t is in fact just e raised to 0, which is 1. 1 and e raised to 2t are two solutions, and the solution we write is a linear combination. That's a complementary solution for the whole thing. If we had only this homogeneous part, then this would be the general solution. So C1 times 1 plus C2 times e raised to 2t. Okay. In this variation of parameters or variation of constants, then our particular solution yp, this is parenthesis t, okay, is a function of t. That will be, we simply vary these constants or coefficients by function u1 plus u2 e2t. And after we find the values of a1 and u1 and u2, the general solution will be yc plus yp, okay, where we find u1 and u2 as follows using the variation of parameters formula. Okay, let's find u1 and u2. For that, we need to determine Wronskian. If you look at the formula, we need to find the Wronskian of these two functions, y1 and y2, 1 and e2t. We just write these functions in the first row and their derivatives in the second row. Derivative. So 1 times that is just that, minus 0 times anything is 0. So just 2 e raised to 2t. Okay, we need this. You'll see in a moment. This Wronskian is needed to determine u1 and u2. Okay. Now from the formula, u1 is given as negative gt y2 over Wronskian of y1 and y2, and we need to integrate this. Okay, there should not be any numbers, and if we don't have any numbers, if we have, we can divide by that. So this is our gt, and this one is our y1, and this is like y2. We just do that. So that is now negative gt is 3 e raised to 2t times y2. y2 is e raised to 2t over Wronskian 2e2t dt. Now we can see e2t cancel. Okay, so 3 halves can be pulled outside. That's negative 3 halves. And now we are left with e raised to 2t dt. Let's integrate e raised to 2t. Exponential functions always itself. Divide by that number 2. And plus is not needed because we are just trying to find a particular solution. So this is negative 3/4 e raised to 2t. That's u1. And u2 will be almost same but no negative gt y1 and Wronskian of y1, y2. That is, gt is 3e2t times y1, that's 1, first solution, over Wronskian we found earlier, 2e2t dt. e2t cancel, because we got same thing. 3 halves can be pulled outside. That leaves 1 dt. 1 integration of 1 is just t. Okay. Now we have u2 as well. Okay, we got all u1 in all the ingredients. Now we write down the solution. So we write down the solutions first. Let's find yp. Then yp as a function of t is u1, which is here negative 3/4 e raised to 2t, plus u2, that is 3/2 t, u2 times e2t. That's yp. And the general solution is for the given question is just the complementary plus particular. Okay, I mean these are all functions of t, and I did not write parenthesis t, but this is still a function of t. yc is found earlier, c1 plus c2 e raised to 2t, plus yp is here negative 3/4, okay, plus minus minus, this one is negative 3/4 e raised to 2t, and this thing, okay, plus I don't have room here, but 3/2 t e raised to 2t. This would be the final answer, but we need to simplify, and these two are like terms if you look at closely. So e2t, so we can write e2t can be factored out, so that is pretty much c2 minus 3/4 of e2t. Okay, these are like terms, and arbitrary constant minus 3/4 is another constant. I can say, okay, c3 e2t, but I can call back this c3 as c2. I'm just renaming. So the final answer we can write is c1 from this one is simply c2 e2t. Okay, c2 minus 3/4 I renamed, that was c3, I renamed back to c2, or you can write c3, doesn't matter, just arbitrary constant anyways. And plus here is 3/2 t e raised to 2t final.